So in today's lesson, we'll be looking at the idea of worldviews and perspectives and how this relates to the study of world issues. We all see the world through a unique lens, and this inevitably impacts how we interpret, approach, and choose to act upon challenges in our lives and society. And in this lesson, we have the following topics that we will be looking at. For one, we will be starting by understanding what we mean by the idea of worldviews and perspectives. Secondly, we'll look at the idea of bias and how it is presented in all aspects of our lives, even in things that we think of as objective, like maps. And finally, we'll end by leaving you to consider what your worldview is. So to start, it's important to recognize that each and every one of us is influenced by a multitude of factors that impact the way we look at the world. And these factors are kind of like an onion. You can peel them back each layer by layer to get to the root of our beliefs and values. So we can start with these entry-level conversations and investigative questions. And behind that, we can start to see the things that influence us, our commonalities, our behaviors, our personal choices. And then behind those are the things that influence, who we are as people. Things like our work, our hobbies, the weather, world events, our personal histories, etc. All of these layers, you peel them back and you see sort of what makes you as a person, what informs your worldview. Who you are as a person is informed by, what experiences you have had. And that's going to be different from person to person. We all come at issues. We all come at life from a unique lens. And coming at a problem from different perspectives can give you wildly different results. Two people can look at the same problem with the same set of facts and come to completely different conclusions. And this is just part of life. So you've probably seen these before. These are optical illusions. You could probably just as easily call them brain failures. Two people can look at the same image and see something completely different. There's nothing different about the image, just the person looking at it is different. So is this a man's face, or is it a person in a parka with their back to us? Is it both? Do you see both of them? Neither answer is wrong. At the same time here, is this a scene of a city, or is this a man's face? Do you see the woman walking in front? Again, it's the exact same picture, but depending on how you focus on different aspects of the picture, you might see something completely different. Even looking at the world is a matter of perspective. The Earth is a sphere, and in space there's no such thing as up or down. While the Earth rotates on its axis, it does make some sense to have the poles as these two endpoints. But which one is up and which one is down is completely arbitrary. The fact that we say the North Pole is at the top of most maps is arbitrary. It could just as easily be the south. So this map would be just as accurate. And in fact, before European cartographers began making world maps in the age of exploration, many Chinese and Arabic map makers commonly put the south at the top of maps. There's no reason why this map is wrong. It shows the exact same information. It's just a matter of perspective that we've decided on kind of standard maps to have north pointing upwards. And maps themselves can be much more than just showing you what the surface of the Earth looks like. Some maps have an explicit thesis statement. This map, for example, distorts regions based on their GDP. So the richer a region is, the higher its gross domestic product, the larger the region looks. So you can see here North America and Western Europe, as well as Japan and South Korea, very large, and then other places around the world, such as Africa, South America, far smaller than they would look like on a conventional map. So this map here has an explicit thesis statement. It's telling you what the world looks like based on wealth. For other maps, though, their thesis statement is more covert. So this map has a purpose. It's trying to argue something to you. But it's not quite as clear. It's not coming right out in your face. This is a map of the British Empire from the 1800s. It's meant to show you how much power and influence Britain had at the time. So you can see here there are outposts literally on every continent where Britain has set up shop. And there's a very famous saying from the 1800s, the sun never sets on the British Empire. And this is sort of showing you that perspective. Britain's showing you how powerful they are and how much influence they have around the world. And this brings us to the idea of bias. Now, in summary, bias is an inclination of temperament or judgment, a personal and sometimes unreasonable judgment. Now, bias is not necessarily a bad thing. I'll hear students all the time throw around this term like it's an insult. They'll read something and tell me this source is bad because it was biased. And it's even made its way into political discourse. Especially in American politics, you'll hear certain politicians talk about the news media as being biased. But bias is not the same thing as prejudice. Everyone has a bias. Bias is an inevitable part of the human experience. Acknowledging that we have biases is important because it helps us to account for the blind spots in our own judgment. And it helps us to get closer to the truth by acknowledging that we do have those biases. And since everybody has a unique perspective, everything you have ever read, heard, or seen is biased in some way. This presentation you're watching right now is biased. Everything you have ever written is biased. Everything you've ever watched on TV or read in a newspaper or saw in a book or saw online is biased. There's no way of getting around that. And it's not necessarily a bad thing. It's good that we acknowledge it. We can't pretend like this doesn't exist. And even things that we kind of take for granted as being objective, things like maps, are in fact biased. Now, the Earth is a sphere. It's three-dimensional. But a map is flat. It's two-dimensional. So it is impossible to produce a map which combines the true shape, bearing, and distance of the world. So inevitably, every map maker has to make certain compromises in order to make their two-dimensional map work. All map projections misrepresent the surface of the Earth in some way. There are errors in distance and distortions of shape across all different map projections. There's just no way of getting around it. It's physically impossible to truly represent the shape of the Earth's continents on a map, on a two-dimensional space. So consequently, all maps impart the biases of their creator onto the map. A knowledgeable map reader, recognizing that a map is both a simplification and a distortion of reality, will look for the clues to the cartographer's purpose and biases. Again, keeping in mind that everything's biased helps us to understand what's going on in everything we read. And so with that in mind, let's have a look at some different map projections. To study this a little closer, we're going to examine 4 common map projections in particular. The first is probably the one you're most familiar with, the Mercator projection. It's been used in navigation since 1569, and it's the most commonly used map throughout the world. Now, in the Mercator projection, lines of latitude and longitude are evenly spaced apart, meaning that if you follow a straight line on the map, you're going in that compass direction. So going up on the map, you're going to be going north, and no matter where you are on the map. Going to the left, you're going to be going west, no matter where you are on the map, and so on. But as a result, this distorts the shape and size of certain regions. So the polar regions, as a result, look bigger than they should be, because the farther north you go, the lines of latitude actually start getting closer together. On this map, though, they look evenly apart. And as a result, the tropics, the areas closer to the equator, look smaller than they should be. However, it's still used by ships and pilots because, again, it's easy to follow. Up is north, left is west, down is south, right is east. It's easy to follow, and it's also used in many atlases in schools because, again, it's easy for people to pick up and sort of understand and get bearing around what latitude and longitude is, what direction everything is, etc. The second map projection we're going to look at is the Robinson projection. So the Robinson projection was used by National Geographic for their official map from 1988 to 1998. Now this one has the opposite problem of the Mercator projection. It minimizes the distortion of size and shape in most regions. However, it badly compresses and distorts the shape of countries in the polar regions. So once you get to the North and South poles, for example, the northern parts of Canada and Greenland look really squished together. So this sort of runs into the opposite problem of the Mercator projection. Another type of map is the Winkel-Triple projection. Now this projection was first created by Oswald Winkel in 1921, and in this map projection, the prime meridian and equator are straight lines, while all other parallels and meridians are curved. And this was the map projection adopted by National Geographic in 1998, replacing the Robinson, as it better represents the size and shape of the Earth's features, especially in the polar regions. So this map here does a better job of sort of compromising between those first two projections. So it's a better representation of what each region looks like, although again, it's still not perfect. It's impossible to be perfect. But this one's trying to compromise those two things. And the final projection to look at here is one called the Gull projection. And as you can see from looking at this here, it's radically different than some of the other ones. Now the Gull projection is used in many textbooks, especially in British schools, and it shows an area-accurate view of the world. So if a continent looks bigger on the map, it's bigger in real life. Its surface area is supposed to be represented accurately. Now, while the land mass of these continents and areas are represented accurately, their shapes are distorted as a result. So here the compromise being made is that yes, if one continent is bigger than another, if Africa is bigger than Europe, it looks bigger on the map, but its shape ends up being distorted. So in the Gull projection, for example, Africa is elongated in order to account for its size differences. And this has been promoted by groups like UNESCO and has been used in British schools. Now, one final note is how perspective can be shaped by one's own philosophy and how that can create a worldview. So here's a little flow chart that you can go through on your own. That's sort of looking at your philosophical or existential worldview. So you kind of start with the question of, do you think God exists? And on the surface, this might seem like a simple binary answer. Some religious people would view this as a binary answer. Either God exists or God does not exist. But it's not that simple. As you can see here, there are dozens of different outcomes. There are dozens of different answers. And it's not a cut and dry yes or no answer. And there's points in between. So for example, one might view themselves as somewhere between a deist and an agnostic. They might sort of adopt parts of philosophies and combine them with others. So it's not necessarily that this is a black and white issue. You can come to many different conclusions from a simple question. And so in summary, in this lesson you learned that individual worldviews are informed by a variety of factors, including personal history, education, and family. Since the Earth is a sphere, it cannot be accurately projected on 2D maps. There are a variety of map projections which have their own biases, and there are many unique existential worldviews.